All right, let's dive deep into the cosmos today because, well, everything we think we know about the universe turns out it might only be a tiny, tiny fraction of the actual story. So let's just start with a huge question right off the bat. What if the stars, the planets, all the galaxies, everything you and I can see is just the tip of the cosmic iceberg? What if the vast majority of reality is, well, completely hidden from us?
And this chart really just lays it all out, doesn't it? Take a look at that tiny little 5% slice labeled normal matter. Yeah, that's us. That's every single star, every planet, and every galaxy we've ever been able to observe. The other 95%? It's a complete mystery, split between two things we can't see at all: dark matter and dark energy.
Okay, so let's tackle the first piece of this puzzle, dark matter. You know, to even understand why scientists think this stuff exists, we have to look at how galaxies behave and ask a really simple question.
Think about it like this. Picture a merry-go-round spinning really, really fast. The faster it spins, the harder it is to just hold on, right? Well, galaxies are spinning incredibly fast. So fast that the stars way out on the edges should have been thrown off into deep space billions of years ago. But they're not. They're still there. So what's holding them together?
Well, scientists have a name for this invisible glue: dark matter. It's this stuff that we literally can't see or touch. It doesn't give off any light, any energy, nothing. But its gravitational pull is so powerful that it's basically the invisible scaffolding holding entire galaxies together.
In this chart, just shows you the evidence so clearly. Based on all the stars and gas we can see, we'd expect the rotation speed to be what you see in that first bar. But what we actually measure is the much, much higher speed in that second bar. That huge gap between what we expect and what we see, well, that's the pull of dark matter.
And here's the kicker: we're not talking about some minor little error in our math. This invisible stuff makes up a staggering 27% of the entire universe. It's this massive cosmic framework all around us, and yet we have never, ever directly seen a single particle of it.
But as mind-bending as that mystery is, it's not even the biggest piece of the cosmic pie. Because while dark matter is acting like a cosmic glue holding things together, there's another, even more powerful force that's actively pushing everything apart. You see, for most of the 20th century, we all thought the universe's expansion, from the Big Bang, would be slowing down. Gravity should be putting the brakes on, right? But in 1998, scientists looking at distant supernova found the complete opposite. The expansion is actually getting faster and faster. And this discovery gave rise to the idea of dark energy. It seems to be some kind of mysterious property of space itself, a force that pushes outward, overpowering gravity on the biggest scales imaginable. It's essentially cosmic anti-gravity.
And if you thought dark matter's 27% was a lot, well, brace yourself. Dark energy is estimated to make up a colossal 68% of the entire universe. This makes it, by a huge margin, the dominant component of our cosmos, the thing that's deciding its ultimate fate.
Just let that sink in for a moment. This quote really puts everything into perspective. When you add up the mysteries of dark matter and dark energy, you have to accept this one humbling conclusion. Everything humanity has ever seen or studied or even dreamed of, it's just a sliver of what's really out there.
So the universe is mostly invisible stuff. Got it. But the weirdness doesn't stop there. The plot actually gets thicker when we look at things we thought we understood, like those supermassive black holes sitting in the center of galaxies. Turns out they might be playing a role we never ever expected. For the longest time, we've seen these supermassive black holes as just cosmic destroyers, right? Giant vacuum cleaners, just gobbling up anything that gets too close. But a totally new theory is emerging. What if they're also cosmic architects? What if the intense energy they blast out actually controls how many new stars are born, basically shaping the evolution of their entire galaxy? And the strange connections just keep coming. When we map out how galaxies are arranged on the largest scales, they aren't just scattered around randomly. Nope. They form this vast, interconnected structure of filaments and clusters we call the cosmic web. And the part that's truly mind-bending is, it looks almost exactly like the structure of neurons in a human brain.
I mean, seriously, look at that. Both of these networks, the one in our heads and the one spanning the cosmos, they follow similar mathematical rules for how they form. So, is this just a crazy coincidence? An example of how patterns just pop up in complex systems? Or could it be hinting at some deeper principle of organization in our universe that we just haven't figured out yet? All of these discoveries, all of these strange connections, they bring us right here. It feels like for every single answer we find, the universe just smiles and hands us a dozen deeper, more fundamental questions.
The sheer scale of it all is it's almost impossible to wrap your head around. Our best guess for the number of galaxies in the observable universe is 2 trillion. That's 2 trillion galaxies, each one with hundreds of billions of stars, all held together by invisible matter and being pushed apart by an invisible energy. So we're left staring into the dark, facing these ultimate mysteries. What is dark matter really? What is dark energy? What happened before the Big Bang? And with 2 trillion galaxies out there, are we really the only ones looking up and asking these questions?
And that leads us to our final thought. Every time we build a better telescope, every time we look a little deeper, we find something that completely rewrites the textbooks. It really makes you wonder, what if after all of this, we've barely even scratched the surface? What if the universe's biggest secret is still out there, just waiting for us to find it?